Right, so question 3. The curve of the equation which satisfies that dy by dx is k, x, 2x minus 1, 4 minus x. P, 2, 7 lies on the curve, and the gradient of the curve at P equals 9. So we're given 2 bits of information for this. Find the value of the constant k. What threw a few people was that the 2 bits of information were given to us, probably quite deliberately, in the opposite order of how we were going to use them. That actually, to find the constant k, we're going to use this bit here. The gradient of the curve at P is 9. Because the gradient is to do with dy by dx. So what that bit that I've just shaded in yellow means is that if x equals 2, that's what happens at P, then dy by dx equals 9. So before we do anything else about integrating it or anything with that, we're going to use that bit of information. So that means that k times 2 times 2 2's minus 1 is equal to 9. I didn't multiply the brackets first because I'm just subbing in a number. So this is just going to give me 2k times 2 times 2 would be 4, take away 1 is 3, is 9, so 6k is 9. So from that we get k is 3 over 2. And we've got the value of k straight away. Alright. Part 2, find the equation of the curve. There were a few people who made careless mistakes in this when I was marking this, including that classic thing of getting the fraction upside down when you've got a simple statement like that. You've really got to be careful because these mistakes will cost you. Find the equation of the curve. Now we're going to use the other bit of information at some point, but if dy by dx equals that, dy by dx is kx 2x minus 1. Remember, before we integrate this, we need to have this in that index form. We need to have this all multiplied out, no brackets in there. So it's nice for us to work with kx times 2x would be, well, k is 3 over 2, of course, isn't it? So that's 3 over 2 times 2 times x gives us 3x squared. And then we've got 3 over 2x times minus 1, so minus 3 over 2x. So that's what we're going to integrate. We're going to undo the differentiation by integrating y gives the integral of 3x squared minus 3 over 2 dx. Remember, in core 2 you're going to get loads of marks for doing your integration, so we're going to do this really carefully, make sure we don't make any mistakes. Add 1 to the power, makes it x cubed. Divide by the 3, so we've got 3 divided by 3, gives us just an x cubed there. If we integrate a constant, then we get the constant times x. So if we integrate 3 over 2, we get 3 over 2x. And what do we have to remember?
Plus c.
Plus c, the constant of integration at the end of that. Oh, it should have missed out the x when I've written it there, haven't I? Thank you. That's an x there, isn't it? So this becomes x squared over 2, so that becomes a 4 on the bottom. Ah, thank you. Okay, so we've got that. This is now where we get to use the other bit of information the question gave us. The question told us that this curve passes through the point P with coordinates 2, 7. So we also know that when x equals 2, y equals 7. So that's our way into finding the constant of integration. 7 is 2 cubed minus 3 quarters of 2 squared plus c. If we simplify this, we've got 7 is 8. 2 cubed, 2 squared would be 4. 3 quarters times 4 is just going to give us 3 there, plus c. We've got 7 equals 5 plus c, so c is 2. And the question said, find the equation of the curve. So we need to go back and put that all together and say y is x cubed minus 3/4 of x squared plus 2. And that is going to be our answer. Right. Which was 5 marks. So, you get a decent amount of marks, really, for what we've done there.